So there's this very famous story about this mathematician, Frederick Gauss, who, when he was in school, he was asked to add up the numbers 1 through 100. And he noticed that there was a really easy way to add up these numbers. If you notice, if I take the first and last number, I get 101. If I add up the second and the second last number, I get 101. If I add the third and the third last number, I get 101. You always get 101, and so you get 101, and how many times do you get it? Well, what you're doing is you're pairing up the numbers, so you're taking 100 and dividing by 2, so 50 times 101, or 5,050. And so you can do this in general. I'll say in general, 1 plus 2 plus 3 all the way up through n would be, well, the sums would be n plus 1, and then how many pairs do I have? There are n numbers, and I divide by 2. So this is going to be our statement right here. This is going to be our PN. And so now what we want to do is we want to prove this formula using induction. Prove the following. For every positive integer n, 1 plus 2 plus 3 all the way up through n is n plus 1 over 2. So we're going to start, like we've started other proofs, with an outline. So remember, induction involves 2 steps. The first of those steps is the basis step. So you need to plug in n equals 1 into your formula and show it's true. So if I plug in n equals 1, on the left-hand side I just have 1. And that's it. And then on the right-hand side, I get 1 times 1 plus 1 over 2. I get 2 over 2, which is equal to 1. So this statement is true. So that completes the basis step. Now let's talk about the inductive step. You're going to assume that the formula is true. For n equal to k, where k is a positive integer. And now, that's the start of the inductive step. What's the end? Maybe I'll scoot down and give myself some room here. The end, you need to show that the formula is true for the next value, which is k plus 1. So you need to show 1 plus 2 plus 3 plus k plus 1. And then if you plug in k plus 1 in your formula, you'll get k plus 1 times k plus 2 over 2. So this tells me what I need to do. In particular, I need to work with this summation here. So I'm going to go back up now try to fill in my 1 plus 2 plus 3 all the way up through k plus 1. Well, we have a formula for the first k terms there. I have this formula right here. So I'm getting k plus 1 over 2 plus that last term, k plus 1. And now I'm going to get a common denominator for my two terms there. My common denominator would be 2. So then I can combine them into a single fraction. And then I can factor out in the numerator. If I factor out a k plus 1, I'm left with k plus 2. And that's what I needed to get to in the end. So now that we've got an outline of our proof, we can write it formally.